In this example, I need to verify the identity. The sine of 3x equals 3 times the sine of x minus 4 times sine cubed x. In working with identities, we often say start on the more complicated side, which in this case looks like the right-hand side. But if you investigate the left-hand side a little more, it has the sine of 3x. We have a formula for the sine of 2x, but we don't have one for the sine of 3x. So I think it will be best to start with the left-hand side. So I'm going to start with the sine of 3x, and I'm going to try and expand that. And here are a few useful identities that might help me with that. The first of which is the sine of a plus b. Because I can write the sine of 3x as the sine of 2x plus x, because 2x plus x adds up to 3x. And now using this identity, wherever you see an a, you're going to put a 2x. Wherever you see a b, you're going to put an x. So now, using this identity, the sine of 2x plus x becomes the sine of 2x times the cosine of x plus the cosine of 2x times the sine of x. So now I don't have a 3x as an argument of any trig functions. I've either got 2x or x as my arguments. But notice we have formulas for the double angle of the sine and the cosine function. But before I go on, look at what we're trying to prove. The only trig function in my answer should be the sine function, and its argument needs to be plain old x. So the first thing I'm going to have to do is get rid of my sine of 2x and my cosine of 2x. So my left-hand side now becomes, instead of the sine of 2x, I'm going to use this identity. So it's going to be 2 sine x cosine x. Oh, excuse my bad handwriting. That is the sine of 2x times the cosine of x. Plus, now comes the trickier one, the cosine of 2a has 3 separate versions. And they will all work, but one will work a whole lot quicker. Looking at the only trig function in my answer being the sine of x, I'm going to have to use this version of the cosine of 2x. So I'm going to have, instead of 2a, I have 2x. So I'm going to have 1 minus 2 sine squared. Remember, my argument is x. That needs to be in parentheses because it's going to be multiplied by the sine of x. So now I have sine x and cosine x here, but I don't have any arguments of 2x left. So let's see how we can simplify this. So on the first term here, the cosine x times cosine x is cosine squared x. So I get 2 sine x times cosine squared x. Now I'm going to have to distribute in this sine x into this parentheses. So sine x times 1 is just plus sine x. And then sine x times negative 2 sine squared x is negative 2 sine cubed x. Now remember, the only trig function I want in my answer is the sine of x. So looking at what I have here, I'm going to have to get rid of this cosine squared x. But hopefully you remember the main Pythagorean identity. And if I want to, for this one, if I want to get cosine squared a all by itself, you just subtract sine squared a from both sides. So now, on my left-hand side, I'm going to get 2 times the sine of x, and now instead of cosine squared x, I'm going to write 1 minus sine squared. Remember, my argument's not a, it's x. Then the rest of it stays the same, plus sine x minus 2 sine cubed x. Now simplifying, I need to distribute in the 2 sine x into my parentheses. 2 sine x times 1 is 2 times sine x. 2 sine x times negative sine squared x is negative 2 sine cubed x plus sine x minus 2 sine cubed x. Now the only thing left is collect up like terms. I have 2 sine x plus sine x is 3 sine x. Then I have negative 2 sine cubed x minus 2 sine cubed x. So that's negative 4 sine cubed x. And is that my right-hand side? 3 sine x minus 4 sine cubed x. So that equals the right-hand side. So I have shown that the left-hand side equals the right-hand side. So I have verified this identity.